evening, everyone. Welcome back to my IVF Answers. As I've told you last week, we are back with Dr. Vladimiro Silva. He's right here. We also had a webinar last week on Thursday. So, as I've mentioned before, he's back, and I'm glad that you are here with us today. And today we will talk about embryo selection, embryo creation. So, Dr. Vladimiro is definitely the person to explain how it all works. And of course, we will start with his presentation on our topic, but afterwards there will be time for your questions. So I hope you have those questions ready. If not, remember, you can type those in the chat section. Dr. Vladimiro, welcome back. And I'm glad that we are here today as well. And I hope you had a nice day and are ready to educate us a bit on our topic today as well.
Hello, Caroline. Good evening to everyone. It's always a pleasure to be here. It's like I feel like I'm already part of the my IVF Answers
Definitely.
family. We've been together so many times. And so, like I said, it's a pleasure. I think today's topic is particularly interesting. I'm going to share my screen. Let's
Definitely.
see it.
Let's do it.
Well, okay. I believe you are already watching my screen.
Yeah,
Okay.
it's all here.
And here we go.
Okay, now we can see it perfectly. So let's go ahead with our presentation. And as I mentioned, please put the questions in the chat. But now we will start with Dr. Silva's presentation. Let's go ahead.
Okay. So, like Caroline was saying, my name is Vladimiro Silva. I'm the CEO of a group of Portuguese clinics, Ferticentro in Coimbra and Procrea in Porto. And tonight we're here to talk about how are the best embryos created and selected for IVF treatment. This is a very broad topic. Okay, we could spend like 2 or 3 days just discussing all of the details here. So I'm just trying to walk you through a summary of what we have on this. What are the tools that we use to select the embryos, to select the best embryos? But let's start from the beginning, because obviously the best embryos, they come from the best sperm and the best eggs. And when we are considering the eggs, for example, female age is obviously the most important factor. We can see it on this graphic. These are the national statistics for IVF from the United States. This is prepared by the Centers for Disease Control, the CDC. And we can see that the probability of a pregnancy declines with female age, which is not no news for anyone here, I believe. But so this is also very associated with the quality of the eggs. So the younger the woman is, the better her eggs are, and the opposite is obviously also true. When we can, for example, when we compare with cycles where we use donor eggs, where the eggs are of good quality, the probability of a pregnancy remains relatively stable. But the probability, but on the green line, we still have the natural with the patient's own eggs. So there is clearly a very important effect of female age on the embryo quality. So we have good embryos here, and we can see great probabilities of success. When we have lower quality embryos, we can see that there is a clear association with the female age. Another thing, because there are 2 parts of it, and now we can also talk about sperm. So there are news, actually, there was kind of public alarm around this topic following some studies made essentially in Denmark, that there was some claiming that there was some evidence for decreasing the quality of the sperm during the past 50 years. And then we can see here, there was this study published on the British Medical Journal a few years ago, where we could see a very clear decline, not only on the overall average sperm count, but also on for example, the patients with the highest sperm count, they were being lower and lower, and patients with smaller sperm counts are increasing their numbers. Obviously, this is not clear because the way that sperm was tested in the 1930s, the 40s, and the 50s are completely different than the methods that we use today. Nowadays, everything is well more accurate, and we can trust a lot more on our numbers when we compare with than what we were doing in the past. Then there was, for example, this study from the United States where apparently there was no downward trend in sperm quality. Okay, according to the sperm of specimen collection, they could see that there was actually some stability between 1970 and 1995. And then there are a lot of factors that can affect this. As an example here, for example, this is a very funny study. I think this came also from Denmark, where they were comparing the quality of the sperm in the winter and in the summer in many different towns. And you can see that in the winter, sperm is always better, okay, in all countries, Edinburgh, Paris, Copenhagen, Turku, in Finland. So, and we can see that actually for example, the best sperm was in Finland, where men had the highest ranks. Apparently, so there is an association with temperature. We knew that for physiological reasons, but obviously this illustrates how careful we need to be when we are looking into those statistics. Probably, if there are any differences in the quality of sperm, those are related with exposure, with the man's lifestyle, with the exposure to toxicants, with obesity, alcohol. I mean, there are a lot of factors. For example, here on this graphic, we can see the World Health Organization published a manual on how to analyze human sperm. And so what they did was they got a few volunteers, and they were doing sperm analysis every 2 or every 3 days for a year and a half. And we can see that within the same man, through the year, there were fluctuations. Okay, so we all have our ups and downs. Obviously, a sperm takes around 90 days to be produced. There are a lot of factors affecting it, but so we need to be mindful of this. Still, we need good sperm to create a good embryo, and that's the take-home message here. What is written, my goal by showing these numbers is to let you know that we need to be careful while looking at it. Sometimes we just don't we can't get the best embryo because we don't have good sperm and good eggs. This is why we have donation treatments, but there are a lot of tools that we can use to understand whether an embryo is good or bad. Okay, tonight. So another important point, because a lot of time patients ask us the question, what's the problem when we're not getting a pregnancy? Is it the egg or is it the sperm? So there was this study on human reproduction. Human reproduction is one of the most important scientific publications in the world. It is published by the European Society for for Human Reproduction and Embryology. And according to this study, they were hypothesizing that in 70 to 80% of so overall, the egg contribution is about 70 to 80%. The sperm contribution goes between 10 to 15%, and the uterus goes with another 10 to 15%. However, when the paternal component is abnormal, it can drastically affect the ability of an embryo to reach the blastocyst stage. So we can get the embryos, but they stop developing in the middle of their development. And then even during the pregnancy, for embryos that actually implant in the uterus, the quality of the sperm can actually also impact the ability of a fetus to develop and result in a live birth. Okay, these are all clues for the overall picture, and so we need to have good quality embryos in order to maximize the odds of having a pregnancy. In this presentation today, I will not be talking about pre-implantation genetic testing. We've talked about that in several other presentations, and also I didn't want this to be too heavy because there are a lot of topics to be addressed. So the first question, because it was also on the title of this presentation, how can we make the best embryos? Okay, there are two techniques that I believe all of you know. The first one is classic IVF. So we stimulate a woman's ovaries for more or less 12 days on average. We try to make her, because every woman is born with around 2 million eggs when they have their first menstruation. So when they start their fertile life, they only have around 400,000 eggs, and one of those eggs is released into the tubes every month if the woman ovulates normally. What happens when we do these cycles is that we stimulate the ovaries to produce, instead of just one of these 400,000 eggs, because those are not mature eggs, those are primordial follicles, so very early stage eggs. So we want those early stage eggs to mature into viable eggs, and so we give hormones. These are the same hormones that are already inside the woman's body, but in higher concentrations, in higher dosages. We make those follicles grow, and when they are big enough, typically when they have a diameter above 17 millimeters, we trigger the ovulation with another hormone, and we do the aspiration. I'm obviously not going into details. So we do the aspiration, we go with a very fine needle into the ovaries, we collect the liquid that's inside every follicle that has been developed inside the ovaries. We do that for both ovaries, obviously if the woman has both ovaries, and in the lab we will put together in the same dish 100,000 progressive mobile spermatozoa that have progressive motility, and the eggs that are obtained. 100,000 spermatozoa for every egg collected. We wait until the next day and we see if theoretically, the strongest of those spermatozoa was capable of getting inside the egg, fertilizing it, and then closing the egg to the other ones and starting the embryo development. The embryo development typically takes 5 to 6 days in the lab, and so we grow from just one cell into more than 100 cells at what we call the blastocyst stage. When we have the blastocyst, we can transfer the embryo into the womb with a very fine cannula, and then we wait for 2 weeks to see if the patient is pregnant or not. Okay, this is a very quick, fast overview. This was the first IVF technique. Okay, the first IVF baby was born in 1978. It's this little girl here. Here she is a few years later with Robert Edwards, one of the main scientists behind this wonderful step of science. He was awarded the Nobel Prize for Medicine in 2010. And here it's a picture of the first Portuguese IVF baby. He actually became a professional footballer. He played for the Portuguese national squad in youth stages. He never made it to the main team. But the reason why I put his photo here is because when I started working in IVF, which was more than 20 years ago, there was a lot of stigma for people because patients were afraid whether their baby would be different from the others. Are these babies normal? This is so, this is all so new. And one of the things that I was showing them at the time was, see, these are normal patients. For example, this guy is one of the most famous football players in the country, and he was actually our first IVF baby in Portugal. So this is normal. Nowadays, we have more than 8 million babies born from IVF. It's a very routine, those are very routine procedures, and the more years go by, the more experience we have, and the more safety we can bring into the process. So classic IVF was the first IVF technique. It started 45 years ago in 1978. Nowadays, we've gone a long way. We have a lot more tools, incredible tools that allow us to be a lot more successful. the most used IVF technique, the most used the technique that we use the most to create embryos is what we call ICSI. ICSI is the acronym for intracytoplasmic sperm injection. Here we can see a photo. This was taken at the a video that was taken at the Ferticentro lab, where we can see this fine needle already collected a sperm, a spermatozoon. He's here. Maybe you can see the dot here inside the needle. Then we use this holding needle on the left-hand side. This is kind of a vacuum that is there to hold the egg steady. We have to position the egg with the polar body here, just to make sure that when we are injecting the sperm, we're not damaging the structures of the egg. Okay, and now we are holding the egg. We have the little sperm here inside the needle, and then we will start puncturing the egg. Okay, we are crossing the external layer, which is called zona pellucida, and so then the embryologist will push, push, push. He will aspirate to break this inner membrane, and then you can see the sperm here, and now we will leave it here. You can see. Here it is. Okay, so we do this in a very gentle way, and then we release the egg, and about 16 to 18 hours later, we will see if we had a fertilization. Okay, this is how life starts in the IVF lab. This gesture that apparently looks so easy and so simple requires a lot of training from the embryologist, requires a lot of equipment in the lab, the perfect conditions, the most sophisticated equipment. Embryologists, which are the people that work inside the labs, they need to train for typically at least a year and a half before they can do one of these procedures on their own, and still they're doing this being under supervision from their older colleagues. And so this is how we make the best embryos. We have a wonderful, we make sure that we have wonderful labs. We make sure that we work with the best culture media. We make sure that we work with the best training people. We implement the best culture inside each clinic, and we develop a culture of continuous training and always improving, testing the best technologies, see if things work before putting them in practice. And we do this over and over in a systematized way, in an analytical way, in order to confirm and address every results. So then what happens, this is what we see in the lab. Okay, for example, this is a real case. Okay, these are all real cases. This also comes from our lab in Coimbra. We can see here a case where we had 12 embryos, and we can see the videos. We put the embryos, once we inject the sperm inside the egg, we put the embryos inside an incubator with a built-in video camera. It's called the embryoscope, and we can see these cells developing in real time. Okay, here, maybe you can't see here, but we have the time that has passed. For example, now we are at 80 hours post-fertilization, and we can see the embryos developing. And now we are already on day 4 and almost on day 5, and we start to have the blastocysts. Okay, so the embryos that started with just one cell divided into 2, 4, and so on. For example, these 5 embryos were taken to be frozen. These ones here were left into observation because there was something wrong with them that was identified with our techniques in the lab. Okay, so there are, as you can see, this is extremely complex. Okay, what happens with these embryos is something that is extremely difficult for the human eye to see, and so it took science a lot of years to really understand the meaning of all of these cell divisions, whether a cell divides into 1, into 2, into 3, whether the division is symmetrical, where the cells have nucleus inside, just one nucleus, multinucleation, whether there is fragmentations in the embryos, how much time does it take from 2 cells to 3 cells to 4 cells to 5 cells, and so on. How is the embryo developing? Is it including all the cells inside the embryo, or is it excluding some of the cells? for example, these embryos, they've stopped developing and they started to degenerate. Was that possible to anticipate from the beginning? So there are a lot of questions that need answer. So in the IVF labs, what we do every day is we classify the embryos. There are many ways of classifying the embryos, and so I'm going to start by talking about the morphological classification. It's the oldest classification. That's what we've been using for more than 20 years. Okay, it's based on static images. We don't need time-lapse. Time-lapse is that technology that allows us to monitor the embryos 24/7. For the morphological classification, we use that back when we didn't have these incubators with a video camera, with a built-in video camera. So we used to take the embryos out of the incubator. We would put the embryos below the microscope, and we would look at them, we would take pictures of them, and then we would classify the embryos based on what we see. For example, these are embryos that are more or less 18 hours post-fertilization. And here we are looking into, for example, the embryo A is a perfect example of a good and normal fertilization. We have two pronuclei, one comes from the father, the other one comes from the mother. We have two polar bodies, so it's a really nice embryo, and the other ones have problems. For example, this one here has 3 pronuclei, which means that it probably has the wrong number of chromosomes. So this is an embryo at risk. It's a triploid. It's a triploid embryo. This one here, I believe it just has 1 pronuclei. We would need to take a better look, but in principle that's it, and so these two in principle would be excluded from the culture. Okay, there are some recent studies that indicate that some of these embryos can be normal, but we have other technologies to assess that. So if it was back in the days where we were just using morphological classification, B and C would be excluded, and we would only stay with embryo A. Then we continue to observe, to look at the embryos. These images are from the Procrear lab. I forgot to mention that. So we came from 1 embryo into 1 cell into 2 cells after 24 hours. After 48 hours, we are already at 4 cells. After 72 hours, we are already at 8 cells at 72 hours. So this is a normal cell division, with each cell dividing perfectly into 2. These embryos are extremely nice. They don't have fragmentation. So these are very good prognosis embryos. Okay, but we don't, this is not enough for us, okay, because we want to wait until we get a blastocyst. What is a blastocyst? Is a day 5 or a day 6 embryo. Why is that? For example, when I was talking about the sperm in the beginning, I was telling you, we know that in the middle of embryo development, the sperm role is particularly important. We don't know exactly from what point, but in theory, it should be from day 3 onwards. So day 4 is also a very important day. We have the embryo is called the morula. The morula is very difficult to classify because the embryo has around 16 cells, but they are very compacted and attached to each other. So the embryo looks a little messy, and it's difficult to understand whether these cells are normal or if they are dividing normally. Here on the right-hand side, we have the beginning of the blastulation, the start of blastulation. We have some liquid here that comes from the cells, and we can see it's like a lake is being formed inside the embryo, and the embryo becomes to look like this. This is a very nice day 5 blastocyst with 2 very clear areas. This is the inner cell mass, and this is the trophoectoderm. These are obviously very good prognosis embryos. That's why we selected them to be in this presentation. And then the embryos start to hatch. Okay, so they start to get out of this outside layer, and on day 6 the embryo looks like this, like we have on the C image. The embryo is already so big that it is difficult to see it in this microscope. Okay, so back in the days we were taking the embryos every day from inside the incubator. looking at them, and then putting the embryos back into the incubator. This is obviously when we take the embryos from inside the incubator, we are exposing them to changes in temperature, into exposure to light. This can cause pH changes in the culture medium. So we need to be fast and very good at doing that. And ideally, we should avoid doing that. This is why all of the major IVF clinics in the world are working with the time-lapse technology, where we have a video camera inside the incubator, so we don't need to take the embryos out. Okay, some clinics take the embryos out to renew the culture media. Some others, like ours, in our case, we prefer to use a single culture media because we believe that it's more helpful for the embryo. It's preferable for the embryo development to not to disturb its environment instead of doing what we consider to be a kind of an aggression to to renew the culture media. Both theories are defensible. Okay, this is just our preferred way. This is how we believe we can get better results, but we respect that others might have different opinions. And then, how do we classify the embryos? Well, we use international criteria. At Ferticentro and Procrear, we use what we call the ASABIR criteria. This is something that is very used in Portugal and Spain. And so according to the type of embryo, so according to the number of cells, the percentage of fragmentation, the symmetry, the existence of more than one nucleus inside each cell, the embryos are graded according to that. And then based on the previous grading and some characteristics that the embryos show on day 4, and then on day 5, and even on day 6, we will issue a classification of the embryo. Okay, so we still use this, okay, because it's the only way for clinics to communicate with each other. So when you go from clinic A to clinic B, you can tell them, well, I've transferred a blastocyst A or a blastocyst B or whatever. But so it's important that every clinic knows how the embryo was classified by the other, but obviously this is not this is an embryo classification based on morphology, which is somehow subjective. It changes from an embryologist to the other, and it certainly changes from a clinic to the other. Okay, and so there are studies that have concluded that morphological classification has a very weak relationship with the probability of an embryo being genetically viable, especially studies where those embryos were analyzed by PGTA, pre-implantation genetic testing, and at the end of the process, we were tell whether an embryo classified as A was more likely to be genetically normal than an embryo classified as B or C or D. And it was not always the case. Actually, there is a very well-known study that with about 1,000 embryos done in Italy, where they saw that apparently there is no differences. So morphological classification, in my opinion, is something from the past. Okay, we still use it because, I mean, I will give you my personal example. I work in this for more than 20 years, and so we are very used to do it. And so I think we will keep classifying the embryos because we kind of need that information. But the decision on whether we should use an embryo or discard it, or whether we should freeze an embryo or transfer that embryo, or to select the best embryo to transfer, we are not basing it on the morphological classification anymore. We're basing it on more sophisticated methods like pre-implantation genetic testing. We have the invasive and the non-invasive one, and also artificial intelligence and morphokinetics, and I will talk a little bit about that. There are other classifications. For example, the Gardner classification is one of the most well-known worldwide. It is used to classify the blastocysts. So you might have heard about the ASABIR classification, the Gardner classification. Those are all different ways of saying the same. How a single static image of an embryo looks a certain number of hours after fertilization occurred. So actually on a certain day after fertilization occurred, because when we do classical IVF, we don't know the exact moment where the sperm entered the egg. Okay, so then we came the era of embryo morphokinetics. What is that? So it all started with the embryoscope. This is an image from an embryoscope. What is this? This is an incubator with the built-in video camera that allows us to culture the embryos continuously from the moment immediately after we insert a sperm inside the egg until just a few minutes before we transfer that embryo into the womb, or until we freeze that embryo. Okay, this allows us to do continuous embryo culture without damaging the embryos, without touching the embryos, without changing the exposure of these embryos to variations in temperature, in humidity, in oxygen pressure, and so on. So this is why we prefer we are all, when I say all, I would say all of the main IVF clinics in the world are migrating to embryo morphokinetics, and obviously this is an expensive equipment, and so some clinics still don't have it, but in the future I believe that all the major clinics will be using it. And when we started using the embryoscope, we got to see how an embryo develops. So this is another video from Ferticentro, and we can see, for example, this is a real case of a real baby, and then we started to see what happens inside the incubator, because remember that we were just taking the embryos out at very specific points in time. So we didn't know what was happening in between. With the embryoscope, we got to see everything. Okay, so for example, this embryo is not so beautiful as some of the other ones that we saw because it has a little fragmentation. But what counts here is that it is forming a very nice blastocyst. Okay, so this is a very good prognosis embryo again. And so the embryoscope opened the window into this. And so we started to try to understand what was happening inside the embryo. And so we started measuring different points in time. For example, the time between ICSI until the formation of the second cell, and the formation of the third cell, and the formation of the fourth cell, and the length of the cell cycle between 2 and 3 cells, and the length of the cell cycle between 2 and 4 cells, and between 3 and 5 cells, and between 3 and 6 cells, and so on. And so we didn't know what was the meaning of all of these findings, and we started analyzing it by computer. Okay, so we started working with models in order to predict how the embryos work, and we could see that we started with the embryos that we knew that implanted, so what we call KID embryos, embryos with known implantation data, KID, and so we could see, well, if this one is implanted and we had a child born from this embryo, probably all of his characteristics are favorable. And then we went and see how much time did it take from 2 to 3 cells, from 3 to 4, and so on. So we were developing scoring models. One of the most well-known is called the KID score. It was developed by Vitrolife. Vitrolife is the manufacturer of the embryoscope, and so they classified the embryos from 1 to 9.9. It is a semi-automatic method. Why is it semi-automatic? Because it relies on the human capacity to identify the moments of cell division and so on. So even though the embryoscope has a semi-automated method of identifying those moments, it needs to be the embryologist to go there and validate that moment is exactly how the system says it is. And then based on those information, and then based on the data from thousands of embryos worldwide, they've developed a model, a prediction model that will say this embryo is more likely to implant than the other one. Okay, so this is still dependent on the embryologist, and everything that is dependent on humans has obviously some degree of subjectivity, and it is a time-consuming model, because for every single embryo we need to register sometimes 25, 26 different parameters, sometimes more, and many times we have like 100 embryos in the lab. Okay, so it's a lot of work to be done by the embryologists, and we need to make sure that we're doing it in a consistent, reproducible way in order for the model to identify properly, to work with proper data, okay, which is not that easy sometimes. And then it came artificial intelligence, okay. Artificial intelligence is frightening people all over the world. People say that machines will rule the world. It could happen, actually. It's being so powerful that it becomes frightening. But nowadays, we obviously expect it that it won't happen. I can tell you that in the IVF world, in the science world, artificial intelligence looks to have a lot of potential. Okay, we are not there at the moment. We are not there yet. Okay, so this means that right now I still trust embryologists more than I trust the machines, but it's progressing a lot, and it will help us a lot. Why is that? Because we are humans, and there are things that the human eye cannot see, and there are so many aspects in the analysis of a developing embryo that we just can't see it, and so it's preferable to just rely on machines that have a much powerful way of looking into things, a much systematized way. So machines don't get tired, machines don't have problems, personal problems at home. They are always focused, always reproducible, and with these new technologies, they can learn. Okay, and that's why we call it artificial intelligence, because these machines can learn. So just also to clarify a little concept, because artificial intelligence is the broader designation. Then we have machine learning. We have models to evaluate embryos that are based on machine learning. This is, for example, when we extract information from fixed images, like we were using with morphological classification. So when we have embryo pictures, and then these machines will learn how to classify by evaluating parameters like homogeneity, contrast, luminosity, circularity, segmentation. I don't even know what these things mean, but so this is a very technical, this is from the engineering domain. So they will just look at the images and say, based on and compare on these images, and comparing to thousands and thousands of embryos, and especially with the embryos that we know that have originated successful pregnancies, we can say that this embryo is more likely to be good or bad. And then on top of that, we have deep learning. So deep learning is about learning from all of the different development pathways that an embryo can go through based on raw images. So while machine learning is looking at fixed images, deep learning is going through the process. So it's the evolution of the embryo that is being evaluated with deep learning. And this is where the most powerful artificial intelligence tools, this is what the most powerful artificial intelligence tools are using these days. Okay, and there are a lot of methods in the market. For example, at Ferticentro and Procrear, we use a software called IMA from a company named AIVF. They provide a score from 1 to 9. Okay, for example, this is a very good prognosis embryo. And for example, when we are assessing an embryo with IMA, it takes us 30 seconds to evaluate an embryo. Why is that? Because it's done by a machine. When it's an embryologist that does it, it takes us 3 minutes and a half every time we look at an embryo, and we are subject to error. Okay, for example, Vitrolife, they have developed another system that is called IDA-Score, and for example, in this study, they were comparing the live birth rates by patients that have good IDA-Score, that so the probability of pregnancy according to the IDA score. And we can see that embryos with the highest IDA score, are more likely to implant. Okay, this proves that this system works as a way to identify the embryos that have a higher likelihood to implant. And the other thing here is that well, it's because this is comparing live birth, and here it's the implantation rate. So it's more what both graphics show is more or less the same. The higher the IDA score, the better the prognosis. And so these tools are actually effective while identifying the best embryos. Okay, and this is the way. For example, at Ferticentro, we did a study together with IVF comparing the kit score, where there is a human intervention, with with the score from the IMA, the AIVF, and we concluded that that IMA was relatively slightly superior to the more manual method. Okay, this is there are a lot of studies being done on these topics. This is one that we presented in an international conference. But the importance here is to know that artificial intelligence is here to stay. It will become more and more powerful. It will, nowadays, there are studies comparing the probability of an embryo being euploid, meaning having a normal number of chromosomes, so the capacity of these artificial intelligence models to identify a euploid embryo. Okay, this is extremely powerful. Okay, and so it will. We're not there yet, like I said, but science is evolving at a very fast rate. But obviously, there is what we call the Gartner hype cycle. When we have an innovation, expectations grow extremely high. We think that some technology will make a revolution, life will not be the same, and so on. I think artificial intelligence has gone through this. Then there's what we call the through of disillusionment. Then we start to identify the problems of using the technology, its flaws, that things are not exactly like they seem to be, and so on. And then there's what we call the slope of enlightenment with the second and third generation products. And then that's when we get to the plateau of productivity. We believe, for example, this author here, he believes that artificial intelligence is probably getting the plateau of productivity. I agree, because we are starting to have artificial intelligence systems in the market. We were doing a lot of work that we didn't know whether it was really working or not. But from our experience at using these artificial intelligence models at our clinics, we can see that the capacity to predict the viability of an embryos is amazing. And we are starting to trust these systems more and more. And when we have doubts, we just decide based on what artificial intelligence tells us, because we know that we are humans, and like all humans, we have flaws. And thank you. Welcome to this brave new world where we are capable of selecting embryos in many different ways. I obviously haven't discussed pre-implantation genetic testing, which is another extremely powerful way of identifying and selecting the best embryos, because we've talked about that in other webinars. And so I'm available and ready for your questions. Thank you so much for listening to me.
Thank you so much, Vladimir. As always, it's been great to have you. Thank you so much for your presentation and some new things.
Thank you, Caroline.
AI, definitely. It's something that is definitely on everyone's mind, I think, recently. So thank you so much for introducing this as well. We don't talk about it, not yet, at least, I think, enough. So
Okay.
Thank you so much for adding this. And now, you know what to do. If you have more questions, there are some ready. Go ahead, type those in. Vladimiro Silva is right here for you, and I'm sure he'd be happy to answer any of your questions. And let's have a look. There are some questions let me go to the first question from Elisa. So what is the significance of blastocyst culture in the context of IVF, and how does it impact the selection of embryos?
Okay, so blastocyst culture is taking the embryos until day 5 or day 6. What I always tell patients is this: extended culture, so extending the culture to day 5 or day 6, will not improve the quality of the embryos. Okay, so if an embryo is not good, it will. That's extended culture won't change that. So it will. If it's bad, it will remain bad. If it's good, it will remain good. However, the more information we have on the embryo, the better, and the better we are prepared to decide what to do with the embryo. Is it a viable embryo that worth being transferred into the womb? Is it an embryo that we should freeze? Should we do PGTA or not? So this is the importance of blastocyst culture is that it allows us to have a lot of information on the embryos, and so this is why we are doing it. I would say that nowadays more than 95% of IVF cycles all over the world are done at the blastocyst stage.
Thank you so much for this question. And now we will go to the next question from Elise as well. So I'm 38, I have experienced recurrent miscarriages. How can my previous pregnancy complications be taken into consideration during the creation and selection of embryos?
When we have a patient with recurrent miscarriages, we strongly recommend the patient to do PGTA. Okay, it's one of the things that at our clinics we strongly advocate for it, because by doing PGTA we can. One more time. PGTA will not improve the quality of the embryos. If the embryo is bad, it will remain bad, but we will know whether that embryo is viable or not. And so when we have, for example, a patient with recurrent miscarriages, what we try to do, that will affect our strategy. So we will try to get as many embryos as possible, so we can test them and see if we can get viable embryos. If we get viable embryos, then that's more likely, at least, that the complications that she had were associated with non-embryonic factors. It could be, if you remember that graphic that I showed in the beginning of my presentation, 10 to 15% of the cases can be associated with endometrium, for instance. And so we need to focus on that. So it will target our diagnosis strategy. So we will do tests to the endometrium, we will address that, or we will just pay more attention in the preparation of the endometrium, we will try different strategies and so on. So the relationship between the history of the patient and what we will do is it will tailor and it will help us to establish a strategy to manage the situation. Okay, so that's it. Caroline, you're on mute.
Sorry, my bad. I'm here, of course. And thank you so much for your next question, Elisa. There's one more, and I don't see more questions. So please, if you have more, you know what to do. And let's have a look. So, yeah, Elisa would like to ask, you've mentioned this during your presentation. Are there any ongoing research or developments in AI for embryo selection that patients should be aware of as they plan their treatment?
So, evolution with AI, evolution happens by the day. For example, this very week we're having a congress of the American Society for Reproductive Medicine in New Orleans, and I know that there will be a lot of presentations on artificial intelligence, so probably there will be news from this congress. Okay, so this is happening almost in real time. Innovation is getting very fast into the clinics, and so that's it. I mean, in my presentation, I've addressed 2 of the systems that exist. There are others, okay, and very quality others. the ones that I showed are the ones that I work with and the ones that I know. But there are certainly other very good quality systems, and it is happening every day. So what artificial intelligence does is this: it will be easier and easier for us, embryologists, technicians, doctors, whatever, to understand the likelihood of an embryo being viable. Okay, I don't know if we will ever get to where we are with pre-implantation genetic testing, but we're getting closer and closer.
Okay, this is here to stay, I think, AI,
Yeah,
when it comes
yeah,
to that, right?
certainly. Yeah.
And I want to ask you additional questions. So do you think there is a chance that AI may actually, kind of take over, and we will no longer, let's say, maybe not need embryologists, obviously, but their job, their task might be a little bit
Um,
reduced?
I
What do you
think
think?
the role of the embryologist will change a lot in the future.
Okay.
Okay, I believe that we will all be validating conclusions from artificial intelligence. So handling the cells, it needs to be us, okay, because
Obviously.
robots they
Yes.
don't move very well. But still, there are some experience. For example, there was a group, I think it was in the United States, where a robot did an ICSI. Okay, there was
Okay.
also a Portuguese scientist involved on that. So the robot already did an ICSI, but we are extremely far away from having robots doing ICSIs routinely.
Okay.
For embryo selection, yes, I think that in a relatively short time, we will all be trusting artificial intelligence for that.
Okay.
I'm not sure if it will replace pre-implantation genetic testing. I
Mhm.
don't I don't see that happening in the short term. Obviously, if you have a webinar done by one of my friends from the IVF company or the Claire or whatever, there are a lot
Mhm.
of companies. They will tell you the opposite, the Chloe, not Claire. So they will be very happy to say that their systems will replace embryologists, but to be honest, I don't think we're there yet.
Okay, that makes perfect sense. Thank you so much. And if I may just one more question. So how long have you been working with those two companies when it comes to AI?
So we have started developing the artificial intelligence algorithm 3 years ago.
Okay.
And so we were testing it at different stages in a routine way, but more in the last, I would say, the last year, maybe a little less than a year, we are using it on a day-to-day basis, on a daily basis. However, we're not. So what we are doing is this: we use everything right now. We classify the embryos
Mhm.
morphologically. We test the morphokinetics because the results comes immediately, automatically, and we compare with artificial intelligence, and then we draw our conclusions. Okay, so we don't fully trust any of the methods. It's still the
Yes.
embryo that makes the final call.
Mhm.
My theory is that maybe 2 or 3 years from now, we will all be using artificial technology because it will prove at a
Yeah.
certain point someone will prove that it is
Yeah.
consistently better.
This is something that is still progressing. We need to wait, but it's still out there and it's going to
Yeah,
be used, I'm sure, right?
yeah,
Thank you so
yeah.
much indeed for my additional questions to you. And as there are no more questions, of course, we will be finishing for today. But as always, I want to remind everyone that if you have more questions, you can always get in touch directly with Vladimiro Silva, and I'm sure he'll be happy to help you out. So his team at Ferticentro and Procrear will be happy to take care of your queries. So don't hesitate. Thank you so much, Vladimir. It's always a pleasure to have you, and I'm sure we are going to see each other quite soon. Thank you so much for today.
Thank
Before
you,
we leave,
Caroline.
anything else you wish to add?
Well, I would just like to thank everyone that spent this evening listening to me. It was a pleasure to be here. If you watch this video on YouTube, then my my vows of good luck for everyone that is going through IVF at this moment. I'm available to help, to assist if everyone tried, and if everyone needs, if anyone needs, and so good luck for everyone. I'm very happy to help.
Thank you
And
so
thank
much.
you for the invitation.
Definitely. And as you can see, there's a comment. Thank you. Very interesting to hear how AI is progressing. True. And I'm sure we
Thank you,
are going
TH.
to we are going to discuss it more and more. That's the future. That is something that is happening right now. So thank you so much for bringing this up as well. And as you know, we will be back next week. So stay tuned for more webinars. We will be talking about different aspects. Actually, next week, there are 4 webinars coming up. So don't hesitate, sign up if you haven't already. And I'm looking forward to see you, Dr. Silva, as always. Thank you so much. Take care.
Thank you.
Good night, everyone. Bye.
Good night. Bye-bye. Thank you.